Well, hello, and I am Mr. Kelly, if you didn't know already, and I will be your physics teacher. So today what we have is our first video lecture, and this is going to be a kinematics intro. And my intro to the intro is this here map of the United States. So we cover a lot of ground here in the United States, from where we live over in New Jersey, from sea to shining sea, and all points in between. Maybe you've traveled around the country a little bit, and if you have done that, you've seen some amazing things, that's for sure. And maybe somewhere along the line you wondered, well, are we there yet? How far do we have to go? When will we be there? These kind of questions. And those questions are related to what we're going to be talking about here. So when we're done with this, there are some things that you should understand afterwards. And one of the things that's going to carry into everything that we do in physics this year is that if you know a few things and you understand how the patterns work and how things are connected, you can find out a lot of more information. And that's really an overriding theme for physics anyway. Okay, so we'd ask maybe some questions that you could kind of bring up, and this could show up in your Cornell notes perhaps, or questions that you should be thinking about and maybe come away with understanding after this is over. So how are we going to do this? How are we going to symbolically represent this information, this kinematic information, and what can we gain by doing this, and how important are the units? So those are questions that we can be asking ourselves. I guess a good question to be asking is, what is kinematics anyway? And kinematics is a description of motion. So we're going to start off, and maybe you should think about that a little bit. What would you use to describe motion if you were going to describe the motion of an object? Well, maybe it would be the speed. That would be a good thing. How fast are you moving? So we're going to be really talking about speed a little bit here. So if we have something that's moving at a steady speed and the speed does not change, that's a constant speed. And we're going to start off with that simplest of scenarios. We know in a trip like this with a car traveling, they're probably not going to move at a constant speed. But we'll start with that simple assumption and try to build it up from there. Now you've been looking at this for a little while now already, right? 400 miles in 5 hours at a constant speed, if that was possible. So what is the speed? Maybe you're already thinking about it. Well, maybe in thinking about it, you've come up with the idea that it would be 80 miles per hour. 400 miles in 5 hours, 80 miles per hour is a speed. So there we go. So I guess if we're talking about speed, we're talking about distance divided by time. Miles divided by time. Distance in miles divided by time in hours gave us a speed in miles per hour. So we're already talking about the units a little bit, as well as the quantities. So here comes the symbolic representation. Instead of saying, writing out every time, speed is equal to distance divided by time, something that you may have known intuitively in solving that question about how fast the car was going, but instead of writing it out like that every time, we're going to put it to symbolic form. So V is equal to D divided by T is the way we're going to word it, and the D and the T for time, of course, and V is going to be the symbol for a constant speed. And you might already be thinking to yourself, why V for speed? And you may already know the answer to that already, but something worth thinking about, that's for sure. Okay, so we're going to use symbolic representation all the way through, and we want to be talking the same language. So we're going to introduce symbols that we're going to use. I've just introduced 3 of them, and then we're going to be of the same understanding of what those symbols mean. So for this problem here, and for every problem that you do, you're going to symbolically represent the information. So when they tell you they covered a distance of 400 miles, here is the symbolic representation. D is equal to 400 miles. And for the time, it's the T is equal to 5 hours. The other thing that we're looking for is going to be the speed, but we're going to use the distance and the time to get there. Notice that the units are important. 400 is not a distance. 400 miles is different. That's a distance. Okay, so we're going to show the calculation symbolically as well. And here, V is equal to D divided by T is going to be shown along with the substitution. V is equal to 400 miles divided by 5 hours, and that is 80 miles per hour. So there you go with how we're going to show our work. Basically, I'm setting you up for how the problems are going to be solved all year long, how you're going to show your work. So you'll identify the information, then you'll show the work, and then we'll go from there. All right, and it looks like, all right, so what is the unit for speed here? Well, hopefully you already got that figured out, miles per hour. So that's the unit for speed. Okay, so solving the problem is a good thing. You may have already thought, hey, I already knew it was 80 miles per hour. Why do I have to show all that work? And that's not a bad question, but I need to see the thought process. So all throughout the school year, you're going to need to show what you're thinking basically in solving the problems. How did you come about getting your answer? So we'll get in the habit of doing that right from the beginning. All right, so explaining your thought process is going to be as important as coming up with the right answer. Okay, so well, I've just said it, so there it is again. You're going to be expected to be able to do that. How did you get your answer? All right, so you're going to show your work. The same stuff I've been saying here. All right, so our steps are going to be symbolically represent the problem, the data, the givens, if you will, then show the calculation, and then give the answer with the correct unit. And that's going to be our steps all the way through. All right, so here is a question, right? Let's see how you do with this one. Why don't you pause the video, give it a shot, see if you can set it up successfully, come back, and then I'll show you the answer that I got. All right, well, welcome back. Let's see how you did here. Okay, so first the problem, symbolically, there's the speed, 20 miles per hour. There is the time, the 5 hours. Those were what they call the givens. That information was given to you. And I'm also writing down here going to be the calculation and the substitution. So V is equal to dt is what we've discussed before, and that means the d is equal to vt. And I just got that by multiplying both sides by t. And as I'll point out shortly again, officially, this is the first kinematic equation that we're going to be using. D is equal to vt. Get us started on the kinematics. Okay, so there's D is equal to vt. And if I'm looking for D rather, I'm going to take my V, 20 miles per hour, and multiply it by 5 hours. Now, since you've already identified in your givens that V is 20 miles per hour and T is 5 hours, you do not have to do that again when you're showing your work. You could just say D is equal to 20 multiplied by 5, and that'll be okay with me. What I'm trying to show here with the fractions is that hours will cancel out and you'll be left with miles. You're probably familiar with that from chemistry. They called it dimensional analysis, and that's what we call it too. So the units will cancel out, and that's important for solving problems. Okay, so 20 multiplied by 5 is 100, and as I mentioned, the unit will come out to miles, and that should make some sense too. So here I have represented the information, I've showed the work, and I've given the answer with the correct units. That's a full credit solution. Okay, so D is equal to VT, as I pointed out before, is the way you are going to see the first kinematic equation. And that's the way I'll write the formula. And then we can manipulate it to solve for distance or speed or time. Okay, so this equation, I've already mentioned this is with a constant speed. Is it possible to do this without a constant speed? Yes, it is. And you could probably think about that already if you had it as an average speed. And with a car trip and a car traveling for 5 hours, more likely the average speed is 80 miles per hour. Very difficult to keep a constant speed of 80 miles per hour for 5 hours given traffic conditions. But an average speed is a useful term as well. So now this equation has been broadened to D is equal to VT, where V is constant or average. All right, let's see what we got here. Let's see what you can do with this one, right? Why don't you give that a try and and we'll go from there. How's that sound? Why don't you pause it, and when you come back, I'll show you my solution. Okay, well, welcome back. I hope you gave it a shot. This one had a wrinkle to it. Did you see the wrinkle? Did you find the wrinkle? Well, let's start with our first step. First step is identifying the information. The speed is 30 miles per hour, and the distance is 600 feet. What's the problem? We could just plug it into d is equal to vt, right? And we'll end up with our answer. But that's not really true. The units are important. Here, the unit for distance is in miles, and in the speed, it's miles per hour, and here it's feet. So I can't just plug it in. The units will not cancel out. So what looked like an easy problem, not so easy. Excuse me. Okay, so there is the problem. So we have to do something about that, and we can certainly do that. First of all, 1 mile is 5,280 feet, and let's find out how many miles we have in 600 feet. Boy, that's going to be less than 1 mile, so I'm already thinking it's going to be a decimal point, right? So I'm going to use that to 3 decimal places. All right, so let's see, your calculator, if you take your 600 feet and divide it by 5,280, the feet, the unit for feet will cancel out, and you'll find out how many miles that is. And your calculator told you a lot more numbers than this, but we're going to round. And the number following, if the number following is 5 and up, we'll round up. And if it's less than 5, we'll keep it where it is. So here there was, you have to do a rounding consideration. But now I've found out how many miles I have. 600 feet is 0.114 miles. This might be a little confusing, right? If it is, make a note in your notes, make a notation in your notes that you need to ask a question about it in class, and we can certainly go over it when we're together in class. But now we are in a position where we're ready to go. We have, again, our speed. This time the distance and the speed are in the same units, so the miles there will cancel out. And here we have our distance, 0.114 miles, our speed, 30 miles per hour, and our time. Now this is algebra, so I'm going to want the time by itself, so I'm going to divide both sides by 30. You do not have to write the units in here. You've already done that over here. I just put it in there for, I don't know, either attempted clarity and hopefully not confusion. But here I'm going to divide both sides by 30 to get t by itself. All of our algebra problems involve that, trying to find one thing by itself so we move everything else to the other side. So here I am taking the 0.114 divided by 30, and I'm finding out I got not very many hours. I got a small part of an hour, 0.0038 hours I'm being told. Okay, let's take that a little bit further and say, because that's, what does that really mean to us? Maybe seconds would be a little bit more helpful for us. So how many seconds is that? Well, 13.7 seconds. Do you know how to get that? All right, well, see if you can, and if not, I'll show you how to do it. Just be sure to ask. All right, so 600 feet in 13.7 seconds. I already messed it up there. 600 feet is about 2 football fields. What could be the object that could cover that in 13.7 seconds? Maybe a cheetah. I already spoiled the punchline there. But there you go. You wouldn't want to be chased by one of them. They can cover a lot of distance in a short amount of time. Faster than we can, that's for sure. All right, so there's the cheetah moving very fast. All right, let's see here. Instantaneous speed is what we'll finish this video with today. And instantaneous speed, you know, I talked about average speed and a constant speed. Instantaneous speed is how fast you're going at some split second. How fast are you going right now? That would be instantaneous speed. And we have devices that will measure instantaneous speed. Can you name one that would do that? A device that would show your instantaneous speed? Well, they can do that with your speedometer. Tell us how fast you're going at a certain point or another. And that is a good idea of an instrument that would show you instantaneous speed. Well, thank you for watching this first video of the year. I look forward to seeing you in class.